Welcome to our session on the entity relationship model or ER model. This is a core concept in database design. ER model helps us plan how to store and connect data before we even create tables or write SQL. Think of it's a blueprint for your database. In ER diagrams, we use rectangles for entities like student or product, ovals for attributes like name or price, diamonds for relationship like buys or enrolls. These diagrams give everyone, developers, analysts, or stakeholders a shared view of the system. Originally developed by Peter Chen in 1976, the ER model is still widely used today in apps, websites, and enterprise systems. Let's now understand where ER modeling fits by talking about data modeling. What is data modeling? Before we build databases, we need to model our data. Data modeling is the process of planning how information is structured and related. It's just like designing a house before construction. We usually create three types of models. Conceptual. What are the entities and how are they related? Logical. What attributes and rules do you have? Physical. How will this work in an actual database? A good data model reduces errors, makes collaboration easier, and ensures our system reflects real world needs. ER model help at the first two levels, conceptual and logical. Let's move forward and define what an ER model is. What is an ER model? An entity relationship model is a visual map of the system's data. It shows entities, what things exist like student, course, attributes, what describe them like name, credits, relationships, how they are linked like enrolls. These diagrams use clear symbols, rectangles for entities, ovals for attributes, diamonds for relationships. Ear diagrams help spot errors, ensure consistent design, and serve as documentation. Next, let's see why we use this model before building database. Why use an ER model? Because it gives clarity. It answers what data do we need? How is it connected? It also avoids redundancy, confusion between teams, data structure problem later. ER models make it easier to work with teams and plan normalization, the process of organizing data efficiently. In short, they save time, reduce mistakes, and improve design. Let's now look at the key building blocks of ER model. Key components of ER models. Every ER diagram includes entities, the core objects, example book, customers, attributes, details about them, example title, age, relationships, how entities are linked, example borrows, places, primary keys to uniquely identify each entity, constraints, rules about participation and cardinality. These are drawn using rectangles, ovals, diamonds, and lines. Understanding these components help you read and design ER diagrams confidently. Let's move on your first component, the entity. Entity types and entity sets. Let's talk about two closely related ideas, entity types and entity sets. An entity type is like a template or blueprint for example, student is an entity type. It defines what kind of information each student should have, their ID, name, date of birth, and so on. An entity set is the actual collection of data, the real life students correctly stored in our system. So if student is the type, then Alice, Bob, and Charlie are instances in the student set. Visually, we represent entity types as rectangles in ER diagrams. Inside the rectangle, we write the name of the entity type. Then we attach the attributes around it using vowels. Why does this distinction matter? Because understanding the difference between the abstract and the real allow us to think clearly about both structure and data in our system. Attributes in ER models. Now let's talk about attributes in ER models. These are essentially the properties or characteristics of an entity. For instance, we were looking at the student entity. Its attributes might be things like name, student ID, date of birth, and mail. But attributes come in different types. Simple attributes are individual like age or gender. Composite attribute can be broken down. Think of name being made up of first name and last name. Derived attributes are calculated from other values. For example, age can be derived from date of birth. And multivalued attributes are those that can have more than one value. A good example is phone numbers, where a person might have more than one. In ER diagrams, attributes are shown using vowels connected to their entity. The primary key is underlined. Understanding attribute types is important because it helps you model your data in a way that's both efficient and realistic. Types of attributes. Let's dive a little deeper into attributes types with a few real world examples. A simple attribute like employee ID is just one value, clear and straightforward. A composite attribute such as address might include street, city, zip, and country. Derived attributes like total salary might be calculated from base salary and bonuses. And for multi-valued attributes, think of skills for an employee. They might have several. When designing ER diagrams, we use dashed vowels for derived attributes, double vowels represents multivalued attributes, composite attributes can be broken down with vowels branching out from a central one. This classification is not just for looks, it actually shapes how we build the tables later when we translate the ER model into a database schema. Keys in ER models. In any database, we need a way to uniquely identify each record. That's where keys come in. In ER models, a key attribute is one that uniquely identifies an entity instance. Without it, we wouldn't be able to distinguish between two similar looking records. Take student ID. It's a perfect example of key. Even if two students have the same number, their IDs will be different. Now, we usually talk about two kinds of keys. Candidate keys. All the possible unique identifiers. Primary key. The one we actually those to use in our system. It's underlined in ER diagrams. Choosing a good key is critical. It should be unique, stable, doesn't change often, and minimal. No extra data that's not necessary. For example, using someone's full name and birth date might be unique, but it's clunky and possibly error prone. That's why we prefer system generated IDs. Primary keys in ER models. Continuing with keys, let's zoom in on primary keys. A primary key is the chosen attribute that uniquely identifies each record in an entity. Every entity must have one. For example, a student might use student ID. A book might use ISBN. In ER diagrams, we underline the primary key to make it stand out. Here is what makes a good primary key. Uniqueness. It should identify every record uniquely. Stability. It should not change often. Minimality. It should be simple and not include extra fields. Using a primary key well helps with indexing, performance, and integrity when we move to actual databases. So always pick up your keys carefully. It's the foundation of your table design. Types of relationships. There are three types: one to one to many to many. One to one. Example: each employee has one badge. One to many. Example: a teacher teaches many students. Many to many. Example: students enroll in many courses. These affect how we structure foreign keys in tables. What is relationship? A relationship shows how two or more entities interact. Example: customer places order, students enroll in course. In ER diagrams, relationships are shown as diamonds. They connect rectangles, entities, and may have their own attributes too. Participation constraints defines whether all entity instances must be in a relationship. Total participation. All instances must participate. Show with double lines. Partial participation. Some may not. Show with single lines. Example: all orders must have order item total, but not all employees supervise others. Cardinality constraints. Cardinality defines how many instances of one entity relates to other. One to one instance only. One to n, one connects to many. Many to many. Many to many. These constraints help enforce business logic and reduce redundancy. Relationship attributes. Sometimes a relationship needs its own data. Example: enrollment between student and course may include grade and date. These are called relationship attributes and are linked to the diamond shape. Weak entities and identifying relationships. A weak entity cannot be uniquely identified on its own. Example: order item needs both order ID and product ID. The link to its owner entity is called an identifying relationship, shown as a double diamond. Generalization. Generalization merges similar entities into one. Example: car and bike become vehicle. Used to simplify design and group shared attributes. Specialization. Opposite of generalization. Breaking one entity into subtypes. Example: employee, manager, clerk, technician. Each subtype can have its own unique attributes. Aggregation. Aggregation treats a relationship as an entity, so it can participate in another relationship. Example: a manager supervises a project handled by a team. We group the relationship and entities into a box, forming an aggregate. Ternary and higher order relationships. Some relationships involve three or more entities. Example: doctor prescribes medicine to patient. These are ternary relationships. Try to convert them into binary relationships when possible for simplicity. ER diagram notation. Standard symbols. Rectangle entity. Oval attribute. Diamond relationship. Underlined text primary key. Double shapes weak entity or multivalued attribute. These symbols help make diagram readable and consistent. Sample year diagram. University database. Entities: student, professor, course. Relationships: enrolls, teaches. Attributes: name, ID, credits. Shows how a real system is modeled visually with ER technique. Converting ER model to tables. Steps to convert ER diagram to database tables. Entities, tables, attributes, columns, primary key, table key, relationships, foreign keys or join tables for M2N. Maintain integrity and normalize where possible. Best practices in ER modeling. Use clear, meaningful names. Minimize redundancy. Normalize when necessary. Clearly define all relationship and constraints. A clean ER diagram leads to well-designed database. Wrap up and practice task. Today we learned what ER models are, how to build and read them, best practices for database design. Practice. Draw an ER diagram for library system with books, members, and loans. Thanks for learning. Keep practicing.